So now after set up our entire project architecture, first of all we need to work on repository project. We need to install all the entity framework related packages in it. First of all we need to install entity framework core. Next we will install entity framework core.design. These all projects must be of .NET 7 because our project and packages version must be same. After this I need to install entity framework core.tools and .SQL server. These entity framework core related packages we needed in this project we installed. So next we need to scaffold our existing database in DB context using entity framework. First of all we need to go in tools, then we need to open NuGet package manager and open its console. Now we need to select repository project, and this repository project is also our startup project. A command which we need to execute to scaffold our database. In this first we have written scaffold DB context. You need to write it as it is. Then our server name, database name and user ID, password. Trust server certificate, which means we are trusting SQL server. Then we are defining which server we are using for our database is SQL server. Then our output folder will be generated in this repository project, and we are defining that our folder name will be entities. Now let's execute this command. Now our DB context class is generated, and against each table we have a DB set. Next we need to create a customer repository folder in this repository project. Now our every repository will represent a interface which we need to implement in its own class. Let's create customer repository interface. Both interface and class name will be same, like here I'm giving customer repository. Just we prefix I in front of our interfaces. So this is our interface which is prefixed by I. Now let's write a class of it in which we will implement our interface. We are actually implementing repository patterns so that our classes are loosely coupled with each other. For that purpose we are using interface and then implementing them in classes. This is just for the sake of loosely coupling so that our classes are not dependent on each other, and we will implement solid principles on them and our code just clean in that way. Also in this case object creation will not a responsibility of our class, but we are implementing dependency inversion in this case. First of all let's implement this class by our interface. Next we need to write a constructor in which we will create DB context object. So we will not create its object directly, but we will inject it by dependency inversion. Now we will write basic CRUD functions in this repository and will implement its functionality in its class. First function we are going to write is get by ID. Also here we are using task-based programming. Now the question is, what is task-based programming? Actually, by default, C# has one main thread. We can create more than one thread using thread or task. Both are used for parallel programming. Task is advanced version which built on top of thread. So we can use await with task-based function to free thread, and by default task is background thread, means it does not block a UI from closing. Other kind of threads are foreground thread that block UI from closing. So this was a generic introduction of task-based programming. We will see it in detail in another video. Okay, one more thing I need to mention here, that our delete and save function will return enum types, which will represent we save our entity, we update our entity, and so on. Let's create an enums folder in DTO project. And create enum here whose name is entity status. First stage will be new, second is updated, and third will be deleted, and fourth will be not updated. Now we will return this enum in our save function, and this is our save customer function. Now next will be our delete customer function, and its return type will also be entity status. And last we will have a listing function in which we will return paginated data. So for this purpose we will return two things. One is list of customers and another is count of customers. For that purpose we will use tuple here. And tuple we use when we need to return more than one item. First will be list of customers and second is long type, which will return the number of customers. Function name will be filter, and argument of this filter functions are filter, which will filter all the records. Second argument will be sort column, which will describe what will be a sorting column. And third will be sort order, which will describe what will be the order of sorting, like descending or ascending. Fourth one is page number, on which page number we want a list. And the last one is page size, what will be the page size of our page on which we want to show our records after getting from DB. These are our basic functions which we need to implement in its class. First of all, we will implement delete by ID. We will get customer by ID. Now in this task-based programming, we will need to write async with task, and where we expect our call from outside, or where we expect our call need to wait for the response, then we write await there. So in this case, until we don't get response from the DB, our thread will be free, and that thread can perform another task. Now, if customer is equal to null, then we will return entity status dot not updated. Otherwise, we will assign true to its is deleted status and save changes in DB. And let's return entity status dot is deleted in this case. Second function will be get by ID, in which we will simply get customer by giving ID. If there exists a function with a particular ID, it will return a customer. Otherwise, it could be nullable. So if we want to make it nullable, then we will put question mark in front of its return type. And that's it for this function. Now we will implement save function, which is exactly like a delete function. The only difference is if we get customer null on the basis of ID, then we will add customer, otherwise we will update it. So now let's see its implementation. Now we will implement last function, which will be a filter function. In this filter function, we will need two things: list of customers and count of customers, as we mentioned earlier. So first of all, we will get count of customer. Let's see. So now we will get the count of those customers whose are not deleted, and they filter out on the criteria of our given filter value, and that count will be saved in our total records variable. Now we will get total records in paginated form. For pagination, first of all, we will copy this already existing count query, and then we will need sorting. For sorting, basically we will need a dynamic sorting. Dynamic sorting is not already exist in link, so for that purpose we install dynamic link. Now by this dynamic link, we will use this order by, and in this we'll pass a string. Then for the sake of pagination, we will use skip and take. Skip will define how many records we need to skip on a particular page, and take will define how many values or records we need to show on the page. At the end, we will return it in the form of list. Now we will return a tuple with the customer list and customers count. So this was the implementation of our repository project. Now in next part we will see the service project.